In a logistics depot outside Chengdu in 2024, a convoy of military supply vehicles completed a 40-kilometer resupply run in complete silence. No engine noise, no exhaust trail, no heat signature detectable from above. The vehicles carrying those supplies were built by BYD, not a classified defense contractor, not a state-owned weapons manufacturer, the same company that sells electric buses to cities in Germany, passenger cars in Australia, and delivery vans to logistics firms in Brazil. BYD has become, quietly and strategically, one of the most significant vehicle manufacturers inside China's defense logistics network. The reason every serious defense analyst in Washington, Brussels, and Tokyo is now paying attention has nothing to do with weapons. It has to do with what silence means on a modern battlefield, what instant torque means when a vehicle needs to move without warning, and what a supply chain that cannot be sanctioned looks like when a conflict begins. BYD did not set out to build a military vehicle company. It set out to win the civilian electric vehicle market. What it built in the process is something that turns out to have military implications. Nobody fully anticipated when the company was still considered a niche Chinese automaker. This video covers what BYD has actually delivered into military-adjacent programs, which parts of the capability are confirmed by open-source military reporting and procurement records, and why the tactical advantages of electric drive and ground logistics are changing the way defense planners think about battlefield mobility. If this kind of analysis is what you are looking for, subscribe now and turn on the notification bell every week on this channel. To understand why BYD's entry into military logistics matters, you have to understand what a conventional military supply convoy actually sounds like. A standard diesel logistics vehicle produces between 85 and 95 decibels of engine noise at operating speed. In mountainous terrain, that sound carries several kilometers. Modern battlefield acoustic sensors, deployed widely by NATO forces and available commercially to any reasonably equipped military, can detect, locate, and track a diesel convoy from distances that put the convoy well within artillery range before it arrives at its destination. Heat signature compounds the problem. Internal combustion engines produce substantial infrared emissions, detectable by airborne thermal imaging systems that are now standard equipment on surveillance drones, costing less than $50,000. A diesel supply convoy approaching a forward position is visible to any adversary with commercial drone capability, which in 2026 describes nearly every state and many non-state actors in active conflict zones. An electric vehicle eliminates both signatures simultaneously, not reduces. Eliminates. An electric drivetrain produces no combustion noise and no exhaust heat. At low speed and battery-only mode, the acoustic profile of a BYD electric logistics platform is comparable to ambient wind noise. Its thermal signature from the drivetrain is a fraction of a diesel equivalent, insufficient to trigger the detection thresholds of standard airborne thermal systems. This is not a theoretical advantage. Ukrainian forces fighting Russian armor since 2022 documented repeatedly that diesel vehicle movements were being tracked and targeted using commercial thermal drone systems available for purchase online. The lesson propagated through every defense planning community that was watching. China was watching closely. BYD was already building the vehicles that addressed the problem. The procurement record for BYD's involvement in Chinese military logistics is not classified in the way that American defense contracting often is. China's defense procurement operates through a different framework, one where the boundary between civilian industrial capacity and military logistics support is deliberately blurred rather than formally separated. Open-source Chinese defense reporting and People's Liberation Army logistics modernization materials document a program called Civil Military Integration, known by its Mandarin abbreviation CMY. Under this framework, civilian manufacturers that meet technical specifications set by the People's Liberation Army Logistics Command are certified to supply vehicles, equipment, and components to military end users, without those transactions appearing in the kind of formal defense procurement records Western analysts typically monitor. BYD is a certified civil-military integration supplier. The specific vehicle programs documented in People's Liberation Army Logistics Modernization Reporting include electric light utility vehicles for base operations, electric supply platform trucks for forward logistics, and electric command vehicle conversions built on BYD's commercial chassis. None of these are weapons platforms. All of them are the unsexy, unglamorous logistics backbone that every military depends on to function, and that every military struggles to protect from detection and interdiction. The numbers that have surfaced in Chinese military publication coverage suggest deployments in the hundreds across multiple theater commands. There are reported operational evaluation programs in Xinjiang, Tibet, and coastal defense districts, where the terrain and operational security requirements made the acoustic and thermal advantages of electric drive particularly relevant. The capability that defense planners find most tactically significant is not stealth. It is the combination of stealth with instant power delivery. Electric motors produce maximum torque from a standstill. There is no gear engagement, no turbocharger spooling, no RPM buildup. When an electric military vehicle needs to accelerate, it accelerates immediately, with full power available in the first fraction of a second. For a logistics vehicle, that characteristic translates directly into survivability. A resupply vehicle that can accelerate from stationary to highway speed in under 4 seconds without generating an acoustic or thermal event that announces its movement, can exit a loading position before an adversary tracking the position can complete a fire mission calculation. A diesel truck taking 12 seconds to reach operational speed while producing 90 decibels of engine noise and a visible exhaust plume does not have that option. The tactical utility is compounded by another BYD-specific advantage that has nothing to do with electric drive. The blade battery resistance to thermal runaway means that a vehicle sustaining ballistic damage to the battery pack does not automatically become a secondary explosion event. Traditional lithium-ion battery chemistry, when penetrated by projectiles, can enter uncontrolled exothermic reactions that are impossible to suppress and create secondary fires affecting surrounding personnel and equipment. BYD's iron phosphate chemistry, the basis of the blade battery, does not behave this way. Nail penetration tests, the standard industry benchmark for battery safety, show no thermal event, no fire, and no gas release. The military implication is a vehicle that can absorb a level of battlefield damage that would disable or destroy a conventional battery vehicle and continue operating. That is not a selling point BYD advertises in its civilian marketing materials. It is a characteristic that People's Liberation Army logistics engineers noticed when evaluating the technology for field deployment. Now the part of this story that the more excitable coverage tends to skip. BYD has not announced a military vehicle. The company's public communications are entirely focused on civilian markets. No BYD executive has given an interview about defense programs. No official Chinese government statement has confirmed the deployment numbers that surface in PLA logistics publications. What exists is a documented civil-military integration certification, open-source reporting in Chinese military trade media, and the logical inference that a company producing hundreds of thousands of electric vehicles per month, with batteries that meet the safety and performance characteristics military logistics requires, is going to supply those vehicles to military end users when the framework for doing so is already in place. The distinction matters because it changes how to interpret the geopolitical concern. Western defense analysts are not worried about BYD building weapons. They are worried about something more structural. BYD's supply chain for military logistics vehicles is entirely domestic. Every battery cell, every motor, every power semiconductor, every chassis component is sourced within China's industrial base. There are no foreign supplier dependencies that can be targeted by sanctions, export controls, or supply chain disruption in a conflict scenario. American military logistics vehicles depend on supply chains that include components from dozens of countries, several of which are not reliable partners in a high-intensity conflict scenario. European defense logistics face the same problem. The lesson of the 2021 global semiconductor shortage, which disrupted military vehicle production programs across NATO members, is that supply chain dependency is a strategic vulnerability. BYD's vertical integration, built over 30 years to win civilian markets, incidentally produced the most sanctions-proof electric vehicle supply chain in existence. That is what scares defense planners. Not the vehicle, the supply chain behind it. The countries most directly affected by this development are those whose military logistics modernization programs plan to adopt electric drive over the next decade, and expected to buy components from the same global supply chain that BYD's civilian success has restructured. Examples include Germany's Bundeswehr Logistics Electrification Program, the British Army's Future Mobility Program, and the U.S. Army's Electric Tactical Vehicle Initiative, which has faced repeated delays, partly due to battery supply chain concerns. Each of these programs is trying to capture the same acoustic and thermal signature advantages that BYD has already delivered to the People's Liberation Army logistics units. They are doing so with battery supply chains that currently depend, to varying degrees, on Chinese cell manufacturing capacity. CATL, the world's largest battery producer, supplies European and American electric vehicle manufacturers, including several defense-adjacent vehicle programs. The strategic irony is complete. Western militaries, trying to reduce their acoustic and thermal signature through electrification, are doing so with batteries sourced from the same industrial ecosystem that supplies the adversary's logistics vehicles. The responses being developed are real but slow. The domestic battery manufacturing initiatives of the U.S. Department of Defense, the European Battery Alliance, and the various government-backed lithium refining programs announced since 2022 are all aimed at this problem. None of them have closed the capability gap yet. The scenario that generates the most concern in defense planning circles is not a direct military confrontation. It is a Taiwan Strait scenario where Chinese logistics capability is evaluated against Western interdiction options. An amphibious operation or a sustained blockade requires supply line maintenance across contested maritime and littoral environments. Logistics vehicles that can resupply forward positions with reduced acoustic and thermal signature, powered by batteries that can sustain ballistic damage without catastrophic failure, and sourced from a supply chain entirely insulated from external disruption, represent a meaningful logistics advantage in that scenario. BYD's role in that scenario is not as a weapons manufacturer. It is the company that built the quiet truck that keeps the ammunition moving. Defense planners describe this as the logistics tail problem, the part of military capability that is least visible in peacetime and most decisive in sustained operations. The country that can sustain its logistics tail under contested conditions longer than its adversary wins the attritional phase of any extended conflict. China has spent a decade deliberately integrating civilian industrial capacity into that logistics tail through the Civil-Military Integration Framework. BYD is the largest and most capable example of what that integration looks like at operational scale. The challenge for Western policymakers trying to respond is that the tools available for managing the security implications of a civilian company's technology are poorly matched to the problem. Export controls on military technology do not apply to civilian electric vehicles. Sanctions on a company supplying logistics support through a domestic civil-military integration framework are legally and practically more complex than sanctions on a company selling weapons directly. And the intelligence picture for a supply relationship operating entirely within China's domestic procurement system is substantially harder to develop than one involving international transactions. The debate inside Western defense and intelligence communities about how to classify and respond to dual-use civilian-military integration is ongoing and unresolved. The BYD case has become a central reference point in that debate, precisely because it illustrates how completely civilian technology development can produce military-relevant capability without ever requiring the company to describe itself as a defense contractor. BYD set out to win the civilian electric vehicle market. It did that. In the process, it built a battery chemistry that does not catch fire when punctured, a supply chain that cannot be meaningfully disrupted by external pressure, and a manufacturing scale that can produce military-relevant vehicles in numbers that no dedicated defense contractor can match at comparable cost. None of that was the plan. All of it is the outcome. The vehicle that completed that silent supply run outside Chengdu in 2024 was not designed for that mission. It was adapted for it. The adaptation worked because the underlying technology happened to solve problems that military engineers had been trying to solve for years through dedicated defense programs at 10 times the cost. That gap between what civilian industrial competition produces and what deliberate military investment produces is the story defense ministries in a dozen countries are now trying to understand. The quiet truck is already in service. The question is how long it takes everyone else to build one. Subscribe now for the follow-up when the U.S. Army's Electric Tactical Vehicle Program publishes its next capability gap assessment. That document will tell you exactly how worried American defense planners actually are.